Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Oabudewa Sos Ugobela Wemet. And without any further ado, let's look at these questions that we have here. Okay, so we are given question 3. It says 4 compounds A to D are used to investigate the factors affecting the melting point, and then the results are obtained as shown in the table below. Then we are given all the way from compound A to D. So compound A has propane, B butane, C butanol, and D butan-1-ol, and we can see the respective melting points there. Then 3.1 is asking us to define the term melting point. So let's run quickly to that. We say melting point is the temperature at which the solid and liquid phases of a substance are at equilibrium. And then 3.2 says the melting points of compounds A and B are compared. 3.2.1 says write down the independent variable for this investigation. Now let's look at A and B. You can see that A and B belong in the same homologous series, that's alkane. But then what's different here? You can see that they have a difference of the chain length. From propane, they added CH2 to make it butane. So the difference here is in the chain length. So that is the independent variable. That is the factor that is affecting our physical property here, the melting point. So we are supposed to say 3.2.1 is the chain length. Right. And then 3.2.2 says explain the difference in the melting point of these two compounds. Right. So what are we supposed to do? Supposed to say both compound A and B have London forces, number 1. Then compound B has a longer chain length than compound A, as we have already stated. Then therefore the London forces in compound B are stronger than those in compound A. More energy is required to overcome the London forces in compound B than those in compound A. Thus compound B has a higher melting point, right? Then 3.3 says which one of the compounds B, C, or D has the lowest vapor pressure? Explain the answer. Now, from the table here, we can see that we are not given any vapor pressures. We are instead given the melting points, but we must comment on the vapor pressure. So what do we know? We must use the relationship. We know that the relationship of the melting point and the vapor pressure is inversely proportional. So what does that mean? It means that in order to look for the compound that has the lowest vapor pressure, I have to actually look for the compound that has the highest melting point. So the highest melting point leads to the lowest vapor pressure. So which compound here between B, C, or D has the highest melting point? It is obviously D, right? So we are supposed to say our solution is D. Why? Because it is the highest melting point. Therefore, it should have the lowest vapor pressure, making use of our relationship, right? Then 3.4 says the melting point of compound C and D are now compared. So we are now comparing C and D, which are obviously not in the same homologous series. Butanol is in the aldehyde homologous series, which we know it has dipole forces, but then butan-1-ol is in the alcohol homologous series, which we know it has hydrogen bonds. Now 3.4.1 says which variable must be kept constant in this experiment. Now if we are comparing molecules or compounds that are not in the same homologous series, we should at least try to have comparable masses. So it's the masses that should be kept constant in order to make this a fair investigation. So the compound should have comparable masses. Right. Then 3.4.2 says refer to the types of intermolecular forces to explain the difference in melting points between compound C and D. Now we know the format that we're going to use is ISE, because now we are comparing compounds that are in different homologous series, right? So remember, identify and then speak of the strength of the intermolecular forces and then speak of the energy involved, right? So make sure that you watch that video that I've linked on the notes, right? And then, okay, 3.4.2, we're going to say compound C has dipole-dipole forces, whereas compound D has hydrogen bonds. Now, we know that hydrogen bonds are stronger than the dipole-dipole forces. That means more energy is required to overcome the intermolecular forces in compound D than in compound C. Thus, compound D has a higher melting point than compound C. And that's how you were supposed to explain this for a total of 4 marks. And then the rest of the question overall is equal to 13 marks. So you know you do not leave any mark to charity when it comes to this topic. You make sure that you collect everything. Right. And then we've came to the end of the lesson, guys. Please press the thumbs up button if you've enjoyed the lesson and then you found it helpful. And then if you've been watching the videos and haven't subscribed yet, what are you waiting for? Please smash that subscribe button. And then if you're watching on Facebook, please like the page and follow. And also don't forget to share the page and share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.